Okay, picture this. There's a box. Inside that box, there's a cat. And, if you believe the bizarre rules of physics, that cat is somehow both alive and dead at the exact same time. It sounds crazy, right? Well, today we're going to pry open that box and look at one of the most famous, most mind-bending ideas in all of science, Schrödinger's cat.
I mean, really, can it? It sounds like a trick question. In our world, things are either one thing or the other. A switch is on or off. You're here or you're there. But what if I told you that on the tiniest, most fundamental level of reality, the rules we live by just completely fall apart? This is the exact puzzle that has had scientists scratching their heads for almost 100 years. So to really get a handle on this cat paradox, we have to go to its home turf, the quantum world. We're talking about the realm of atoms and particles, and down here, our everyday common sense is completely useless. Things can be in many places at once, and they can exist in this strange, fuzzy blend of every possibility. The key idea here, the one that makes everything else possible, is called superposition. The best way to think about it is like a spinning coin. While it's spinning in the air, before it lands, is it heads or is it tails? You could say it's kind of in a state of being both possibilities at once. Well, a quantum particle is just like that. Until you look at it, until you measure it, it exists in a blur of all its potential outcomes, all at the same time. But back in 1935, a brilliant physicist named Erwin Schrödinger and his friend Albert Einstein thought this was just ridiculous. I mean, sure, maybe it works for a tiny, single atom, but for a cat, a whole living, breathing animal, no way. He actually came up with his famous experiment to make fun of the idea, to show just how absurd it would be if you applied these quantum rules to our big, everyday world. So he dreamed up an experiment, and I have to stress this part because it's super important. This was only ever a thought experiment. It only happened in his imagination. It was never actually built, and absolutely no cats were ever in any danger, okay? Good. The setup he imagined is actually pretty simple, but also kind of diabolical. You take a cat and put it in a steel box, totally sealed off. Inside with the cat is a tiny radioactive atom. Now, this atom has a perfect 50-50 chance of decaying in the next hour. If it decays, a detector picks it up, which triggers a little hammer to smash a vial of poison, and, well, that's it for the cat. If the atom doesn't decay, nothing happens, and the cat's perfectly fine. And right there, that's the crucial link. The fate of a big, macroscopic thing, the cat, is now tied directly to a random, microscopic quantum event. Remember, that little atom, until we look at it, is in a superposition. It's in a state of both decayed and not decayed at the same time. So, what on earth does that mean for the cat? This is where it gets completely weird. The shocking part of it all. According to the laws of quantum mechanics, since the atom state is fuzzy and undecided, the entire system inside that box must also be fuzzy and undecided. The hammer is both fallen and not fallen. The poison is both released and still in the vial. And the cat? The cat is trapped in a ghostly quantum state of being simultaneously alive and dead. This question gets right to the heart of the whole mystery. When does all this quantum weirdness just stop? The instant we open the box, we know what we'll see, right? We'll see either a living cat or a dead cat, never both. This is called the measurement problem, and it's one of the biggest unanswered questions in physics. What is it about the simple act of looking that forces the universe to finally make up its mind and pick one reality over the other? But here's the amazing twist in the story. The very thing that Schrödinger invented to show how silly quantum mechanics was has now become the blueprint for a whole new technological revolution. We're actually building versions of his paradox in laboratories right now. That's right, those weird cat states that he thought were a fatal flaw in the theory. Modern physicists look at them and see a massive opportunity. They realize that if you could actually create and control these super delicate blended states, you could build computers that can perform calculations way beyond the reach of even the world's most powerful supercomputers. So say hello to the cat qubit. It's the building block for a brand new kind of quantum computer. Only instead of a cat being alive and dead, it uses a bunch of light particles, photons, that are put into a superposition of two totally opposite states. It's like having a computer bit that can be a 0 and a 1 at the exact same time. So why is that such a big deal? Well, the number one problem for quantum computers is that they are incredibly fragile. They make a ton of errors. But these cat qubits have a kind of built-in error protection. The two states are so different from each other that it's really hard for the outside world to accidentally flip one into the other. This makes them way more stable, and it could be a massive shortcut to building a quantum computer that's actually useful.
So how do you keep these fragile cat states from collapsing back into reality? You have to isolate them like crazy. You have to get them unbelievably cold. We're talking 10 millikelvin. That's just a tiny fraction of a degree above absolute zero. It's colder than the deepest, darkest void of outer space.
So look how far we've come. We started with a quirky thought experiment, turned it into a real-world tool, but the cat's true legacy, the thing that really sticks with you, is how it forces us to ask some really deep questions about the universe itself. This experiment really puts two completely different views of the world head-to-head. On one hand, there's the idea of an objective reality, that the universe is out there with definite properties whether we're looking at it or not. But on the other hand, there's this new quantum idea, that reality is fuzzy, undecided, and only snaps into sharp focus when something or someone observes it. And that is a seriously mind-bending thought. What if the universe isn't like a movie that just plays out regardless of whether there's an audience? What if, at the most fundamental level, the act of observing isn't just about finding out what's there, but it's actually about participating in what gets to be real in the first place?
You see, Schrödinger's experiment started out as a joke, a way to poke holes in a new theory. But it ended up uncovering this profound mystery about our own relationship with the cosmos. And it leaves us with one final, haunting question.
When you finally open that box, and that whole wave of fuzzy possibilities collapses into one single reality, a live cat or a dead one, what role did you just play? Are you just a passive observer discovering a fact that was already true? Or did your act of looking in that one single moment actually help create that reality? What do you think?